Ladies and gentlemen, Salam Sejahtera and a very good morning. On behalf of the organizers PAM Sabah Chapter and PAM KL, it is my honor to welcome you to the webinar this morning. I am Justin and I will be your moderator for today. Before we proceed, please bear with me as we go through a few housekeeping reminders. As everyone is probably aware of by now, if at any time during the session you have a question, kindly submit your question through the Q&A prompt so that it can be compiled for the speaker to answer during the Q&A session at the end of his presentation. Secondly, and as highlighted in the introduction slides, please remember to key in your sign in and sign out code when prompted. Please also have a pen or pencil handy to write down the codes, as you will need to fill in a feedback form at the end of the session. This is so that your attendance can be confirmed and verified for eligibility of today's CPD point. Next, please allow me to introduce our speaker for today. Architect Chong Lee Siong graduated with a Bachelor of Arts in Architecture as well as a Bachelor in Architecture with Honours from Deakin University. Lee Siong was a council member of Pertubuhan Architect Malaysia and has served in the Practice Projects Committee, the Disciplinary Committee, the Building Standards and Legislation Committee, and the Continuous Professional Development Committee. He has also served as Honorary Secretary in the 2006 to 2007 term and as Vice President during the 2007 to 2008 term. Architect Chong Lee Siong is active in the pursuit of the study of fire safety engineering from an architectural perspective. He is a member of the UK Institute of Fire Engineers and contributed to the drafting of the current Uniform Building Bylaws, the publication, The Guide to Fire Protection in Malaysia, and has delivered numerous papers on the application and interpretation of fire safety provisions in architectural designs. He has also shared his expertise as guest lecturer and external examiner to the architecture faculties of University Malaya, University Science Malaysia, University Putra Malaysia, International Islamic University of Malaysia, Taylor's University, and Tunku Abdul Rahman University and College. The architectural practice of Lee Siong Architect was established in the year 1994. Current and past projects include a wide array of projects from apartments to luxury condominiums, small and large industrial complexes and office buildings. A particular expertise is in the planning and design of clean manufacturing facilities for the food and beverage, electronics, aeronautical, and automotive industries. Without further ado, let me now pass the time to Architect Chong Lee Siong to start today's webinar. Architect Chong Lee Siong, please.
Hi, good morning, everybody. Thank you so much for this opportunity. Good morning. Thank you so much. We did part one of this series of seminars. I think a few months ago. I was back in December last year, I think. We covered part one, and today we'll continue on to finish off the balance of this series called the Architect's Guide to Designing for Fire Safety. So this is part two. Allow me to just share my screen. All right. Okay. Now, just to recap, when we did part one, we went through the four aspects of fire safety, namely evacuation, passive containment, and the third and the fourth aspect of fire safety on the basic concepts is active intervention and access for firefighting and rescue. And again, to recap, we are referring to the UBBL. We're using the UBBL as a basis for the contents of this seminar. And I've always have to reiterate that the Uniform Building Bylaws, for all intents and purposes, it is just a set of laws. It is not a document specifically written as a guiding document or as an educational document for the purposes of us using as a basis for us to figure out or for us to learn on how to design for fire safety. It is, for all intents and purposes, just a set of laws. It is called the bylaws. It's gazetted by the Act of Parliament, which means that if you don't do it according to the law, you're actually breaking the law. Okay, so it's a criminal thing. But having said that, it is near impossible for us to apply the laws if we actually do not know the fundamental reasons on how all the concepts and the principles and the figures and dimensions and all that was prescribed in the bylaw came about. So just to recap, matters of evacuation, passive containment, active intervention, these will be very specific prescriptions with references to purpose group, the type of building that you're designing, that is, and the occupancy of that purpose group of the buildings, its various components, the type of the building, the size of the building, the height of the building, the volume of the building. Evacuation, passive containment, and active intervention prescriptions would be catered for in the body of the UBBL, and in particular via the schedules 5, 6, 7, 8, 9, and 10. Then, for designing matters with respect to access for firefighting and rescue, okay, these prescriptions are of course in the UBBL, of course, but the prescriptions will be in reference to building height and volume for all the building types. Yep, so you can see here, when it comes to evacuation, passive containment, active intervention, they are very, very specific prescriptions related to the purpose group of the building, type and volume of the building, size of the building, configuration of the building. But when it comes to designing when it comes to the prescriptions for access and for firefighting and rescue, you'll find that the prescriptions apply to all buildings. There'll be no exceptions. It applies to all buildings with reference to its height and volume only. Right, so irregardless of whether you're doing a residential building or a commercial building and all that, just by reference to its height and volume, the prescriptions for designing for access for firefighting and rescue is the same for all the building types, as opposed to the very specific prescriptions for the different purpose groups and the different building types for specification for prescriptions of evacuation, passive containment, and active intervention. Again, to recap, when we're designing for fire safety, we have to first understand the nature of fire. As what Sun Tzu in the Art of War says, in order to fight your enemy, in order to fight the war, to fight your enemy, you must first know your enemy. So in this case, let's recap what is the nature of fire. We have seen from the part 1, we've described this one, where fire starts with the ignition, then you reach the condition known as untenable condition. And this is the time where, this is the short time where it's known as the available safe egress time between the ignition of the fire and when the conditions become untenable. Usually conditions become untenable when the smoke layer comes down, when there's generally when the smoke layer comes down. So it's a very, very short period of time between the ignition of fire, even way before the fire reaches its full-blown flash-over status. Untenable conditions you reach very, very early. And here we've investigated in part 1 the concept of the time taken, the time delay taken for the detection of the initial fire, the raising of the alarm, and the time delay to the actual recognition that it is a fire and people will have to start to move to evacuate, and leading to total evacuation. And we have also understood the concept now that the time taken from the ignition of the fire to the total evacuation of people, that time is known as a safe egress time. And we've also understood now the factor for purposes of designing purposes for safety, the factor of safety is 0.75 of asset. So if you've got the given asset time from the initial of fire to untenable conditions, you have to design the building to allow for the total evacuation, first detection, alarm movement, and then total evacuation within a required safe egress time, which ideally should be measured to be less than 3/4 of the available safe egress time, available asset time. And when we come down to now, in terms of active equipment and active intervention, we are really looking at first detection and alarm. What are the mechanical and the active systems that allow us to facilitate or to assist us in the detection of the fire and in the raising of the alarm. Then the rest of it will be on active containment and extinguishment. Right? If you recall, the first three principles of designing for fire safety, the first one is definitely evacuation. Design for evacuation. First priority, evacuate the occupants. Then second priority is to contain the fire in that one location at one time. Yeah, then thereafter will be the active extinguishments and all that, leading to the access for firefighting and rescue. Yeah, so these two parts here are very, very important: detection and alarm and active containment and extinguishment. I'll show this video again. We have seen this when we did part 1. To recap, this is a recreation of a room of a nightclub fire somewhere in the US of A, many, many years ago. This nightclub fire was famous for the fact that it was a nightclub with a live performance, and the party goers and all that, and all the revelers are in the nightclub. I think they had about 300 or 400 people packed into a very small space. The live performance were using pyrotechnics, and when the pyrotechnics as part of the performance went off, the fire started. And of course, when the fire started, a lot of people still thought that was part of the performance. They're using pyrotechnics, you see. So when the ceiling started to be on fire and all that, a lot of people thought that, oh, that was part of the performance. Wow, fantastic. It's a live performance with fire. Then the situation got bad very, very quickly. And when people tried to exit the building, tried to evacuate the building, the bouncers at the gates were locking off the gates to prevent people from leaving because they haven't paid for the drinks and things like that. You know, so it was a disaster. Really, a very, very fatal situation. Not very good at all. But however, after the incident, a lot of studies was made on this incident, and it included making life-size mock-ups of the room for them to recreate the scene, to try and determine what actually happened, to study the effects of what actually happened. So I'll replay this video again. You've seen it in the part 1, but I'll just replay it again. This is the recreation of the room. And this one is on a non-sprinklered scenario, which is the exact scenario of the room, that the nightclub did not have sprinklers. So let me just play again. Now, just take note of the time bar at the bottom over here. Okay, this is a time bar. Okay, ignition. The fire have just started. And the backdrop, 12 seconds. $24 seconds, and the ceiling has caught on fire. The smoke is being developed now. 35 seconds. The fire is well on the way. At 50 seconds, you'll find that the superheated gas has already accumulated on the ceiling. And the smoke layer, look at the smoke layer now. At 1 minute, the super hot gases and the smoke is coming down now. Right, at just 1 minute and 13 seconds, flashover has occurred on the backstage, and the smoke has come down to less than 1 meter. And at less than 1.5 minutes, the condition has become untenable. Yeah, in just less than 1.5 minutes, the condition is now totally untenable. 1.5 minutes. Yeah? It's totally untenable now. Flashover has occurred on the stage, and the smoke layer has come all the way down. So now let's look at this new scenario, and this is a different scenario here. Again, it's exactly the same replication of the mock-up of the same room. Now this time here, they have installed sprinklers in this mock-up. So let's look at the difference. Let's look at what are the difference. Now it is sprinkler. It's exactly the same scenario. Look at the time chart over here. So the fire has started. In 10 seconds, the fire has reached the ceiling. It's caught hold. In 15 seconds, yes, the ceiling has started burning. And in 25 seconds, the smoke has started appearing. And in 28 seconds, the sprinklers have kicked in. Right, so the sprinklers are the sprinklers are deployed now. Right, sprinklers have kicked in. 43 seconds, 44 seconds, 50 seconds, and 55 seconds. Now, if you compare to what happened on the first scenario, by this time, if you compare to the first scenario, by this time, by 1 minute, the smoke layer is already coming down and flashover has already occurred. And in 1.5 minutes, at this same time, in 1.5 minutes without sprinklers, the place here would have been totally untenable already. The smoke has come all the way down and flashover has occurred. And in the actual incident, all the people who have not been able to exit the premise have already perished with asphyxiation and result from heat exposure. But when you have sprinkled the building, the sprinklers kicked in almost immediately once the flames reached the temperature on the ceiling, and by 1.5 minutes, the fire, for all intents and purposes, have been extinguished. What you see here, just all the water mist. Yeah, that's in the room. Okay, so this one demonstrates the effects of sprinklers. This leads us then to the 10th schedule. There are a lot of amendments that we have made to the UBBL from 1984 to 2012 in recognition of the fact that the installation of active systems, especially sprinklers, it's very important. Now, while we are not saying that sprinklers should be made mandatory for all buildings, because obviously that's not practical, it doesn't serve its purpose, and in many ways it's really over the top. But what we have done is that we've actually recognized that it is very important that some form of active extinguishment must be provided, and that is very important. Yeah. So in the amendments to the 10th schedule, the first things we did was that for all small residential buildings and all, we've introduced the specific requirement for at least the installation of portable fire extinguishers. And for early detection, smoke detection of the self-contained type is to be provided at the top of the staircase for small residential buildings. So at the very least, when you hand over a new building, as part of the requirement for your building plans approval and part of your requirement for CCC, of course, you must at least, the residential units must be at least equipped with a portable fire extinguisher. No skin off anybody's back. The cost is absolutely minimal, but at least it introduces people to the presence of a fire extinguisher, and I appreciate it. That that's something that we must have. Then when you go on to the other parts, there are a lot of refinements with regards to the thresholds as to when we will require the installation of hose reels, sprinklers, and alarms and detections. So a lot of these are very, very minute adjustments, but it just helps to enhance the basic requirements. And it leads us to this very important element over here. Now we've got a very clear definition of what constitutes an open structure and what constitutes an open corridor. There has been all throughout our practice, as we have all realized, we've always said that, okay, if it's an open corridor or if it's an open structure, or we don't need smoke evacuation and all that. Actually, that's not quite true. The requirements for smoke and all that, I will describe it a bit later. It is governed under the UBPL with reference to the Malaysian standards. And that is very, very clear. Requirements of smoke evacuation or smoke control systems of some sort is dependent entirely on the floor areas and the volume of the building. But however, when it comes to open structures and open corridors, there are certain very specific concessions. They're not waivers, but they are just concessions that recognizes the fact that if you design a building as an open structure, or if you design the building with open corridors, a big degree of the risk has been mitigated. So therefore, you are allowed a certain leeway in terms of what active systems that you can install, right? But first, let us evaluate what exactly makes up an open structure and what exactly makes up an open corridor. What does the definition actually say? Let's look at open corridors and open structures. First, the open structure in the UBPL is defined as, we are referring to the perimeter walls as an open structure. It's defined as the total surface area of openings of the perimeter walls, that is to be no less than 40% of the total perimeter wall area enclosing the floor or compartment. And you must also comply with the second item, the openings that you so made is to be shaped and located in such a way that total length in plan of the openings is to be no less than 50% of the perimeter of the floor or compartment. So there are two elements over here. One is the total surface area of the openings. 40% of the perimeter wall. That means for it to qualify as an open structure, the surface area of the walls, at least 40% of it must be permanently open to the atmosphere. And the openings have to be located such that it will encompass in plan, when you look at it, plan, at least 50% of the perimeter of the walls will have an opening. Right, okay, now, and the openings here is to be open to the outside, they're basically open to the atmosphere, or to an enclosed space or permitted air wells. Yeah? So this one allows us for openings that are open onto permitted air wells, like in a high-rise building or courtyard buildings and all that, for that opening to be regarded as an opening for this purpose. Any individual opening having a surface area of less than 600 square millimeters or a width opening of less than 25 millimeters not to be regarded as an opening for this purpose. Now, this one is just to be able to control the minimum size of, say, a perforation. If you do a wall and you put it as a perforated wall, if the individual openings are less than 1 square inch, that's what that's where the 25 millimeter comes from, and 600 millimeter square. So it's less than 1 square inch. So any openings which are less than 1 square inch shall not be regarded as an opening. So you do not add that into the total opening area. The whole intention of this is so that if we want to do an open structure, just ensure whatever it is that you use to make your wall actually contains openings that can be regarded as an opening that will allow the total free flow of air, or in this case in particular, the free flow of smoke for ventilation purposes into the space. Right, and how do we apply this? Let's take this hypothetical example over here. You've got a building, let's just say the perimeter wall is 5 meters high. It's a building 25 meters by 50 meters. 25 meters wide, 50 meters in length. So the basic calculation here, total perimeter length, 25 meters plus 50 meters by 2, etc., etc. So the total perimeter length of this building is 150 meters. So the minimum requirement is 50 meters for it to be opening. So we will need openings to be of a length placed anywhere along the perimeter walls. Total length of the openings to be no more than to be no less than 75 meters, 50% of the perimeter. So then total perimeter wall area, 150 meters by 5, it's 750 square meters. So the minimum openings, the minimum surface area of the opening, minimum 40, is 300 square millimeters. Okay, so this one sets the benchmark for this one. It shall not be less than 75 meters in length, the openings, and it shall not be less than 300 square meters in terms of surface area. So if we just do the hypothetical scenario, it can be this. So 4 meters of height of opening, leaving a 1 meter span row, 25 by 50, etc., etc. Okay, so this one will be the bare minimum compliance for this structure to be regarded as an open structure. Now, that is how bylaws are actually written. We can't write a bylaw to give you all the scenarios. So a bylaw is really just a law. It says that you cannot do it less than this, you cannot do it more than that. All right, so the bylaw is written in such a way that we've analyzed it to say that, okay, at the very minimum, what is the absolute minimum scenario we can accept for this thing to be classified in open structure? So by testing it, if you look at it this way, if someone actually does it this way, absolute minimum compliance, he places it in this manner, we find that this structure can be regarded as an open structure already because it fulfilled the criteria of 40% opening. So if I use to start in here, you've got very, very big openings over here that gives you the clear space for the hot smoke in order to be dispersed out of the building. And more importantly, the 50% of the perimeter length allows then that you create a natural cross ventilation in this manner, right? So say if a fire is starting over here, the fire will naturally be able, the hot smoke and all that will naturally be able to move out from, to be dispersed from the building, and you'll be able to get cold drafts or fresh air to come in here to make up and to dilute the air inside, because you get cross ventilation at the very, very minimum compliance. And anything beyond this would actually be an improvement. So the minimum compliance already is sufficient for our purpose. Anything more than this will be an improvement. Say, for example, we take that opening over there and we place it over here. So the total area openings is still exactly the same, but by placing it over here, it is even better, because now you get cross ventilation over 3/4 of the floor area. By just a diagrammatic approach, you're getting cross ventilation over 3/4 of the floor area. Now, what if I cut off this opening on this side and put it on the other wall like this? The surface areas are exactly the same. It complies with the bare minimum requirements of the prescriptions. And this is even better now. Now we've got cross ventilation over 100% of the floor area. Right, and so on and so forth. We take another scenario. That's now these openings are currently, this scenario shows it at 4 meters. Let's take another scenario where we reduce the opening on the walls to 3 meter high. So with the narrower opening, 3 meters high, the requirement for the minimum square area is still the same. So this one naturally means that you'll have to compensate the 1 meter less in height by the additional length to make back the same surface area. So that's even better now. you're maintaining the same surface area, but the length, the total perimeter length of the opening versus the perimeter wall is now increased. It's more than 50% now. Yeah. So if you do something like this, is totally acceptable because now you got 100% cross ventilation over the floor area. And another scenario, if you make the openings even narrower, now you go down to the opening of just 2 meters. Fantastic. Yeah, you say, okay, so the openings are now 2 meters, but by keeping the same surface area, now you've got the openings on the entire circumference or on the entire perimeter of the open structure. So this one definitely will also work. Huh? So this is how the bylaws are written. It just gives you the bookmarks for the minimum compliance. And with our creativity as architects, this is where we really dial it in. So it is not so much of a case of us asking for waivers. Oh, can I do it this way or can I do it that way? No, it really is. Just understand the basic, the very basic minimum compliance. Then from there, our creativity is the one that would then make the building, make the design work for this purpose. Right, now let's look at a scenario of an open corridor. Exactly the same reference. The only difference is that for an open corridor, the total surface area of the opening is now no less than 25%. And for the open structure, it is 40%. But for open corridor, it is now 25%. Now, why is that so? Well, we fully understand that, say, if you're building a single loaded corridor, single loaded apartment building, corridor is only opening on one side, it is not quite possible for you to have 40%, you see, because the other half would be the apartments, the accommodation units themselves. So yeah, on the recognition, the surface area of opening for open corridor is reduced to 25%. But this is also the minimum. Please make it bigger whenever you can. This is the absolute minimum. The openings to be shaped and located in such a way that total length in plan is no less than 50%. So this one remains the same. The purpose of the 50%, as you recall, is so that at the very minimum compliance, you'll get cross ventilation over the floor area. In this case, it'll be over the floor area of the corridor. Right? And the same prescription applies as to what constitutes an opening. If you look at this one here, this example, this is a single loaded corridor. So a very basic compliance is like that. If you can just have the full perimeter opening on one side of the corridor, you'll find that it complies very easily. So it's designed for that. Now, what happens when you have double loaded corridors, like in a case like this? Yeah, now this is where the permitted air well thing comes in. We recognize that an air well that's designed in accordance to the minimum prescriptions of a permitted air well in the UBBL would function very well as part of the ventilation and the cross ventilation, smoke dispersion for corridors, for open corridors. So the same principle applies. Just ensure that the full openings comply with the no less than 25%, and the way in which you position the openings would be more than 50% of the perimeter length of the corridor. Yeah, so it's exactly the same principle. And we find that this one really helps us a lot. Now, of course, having said that, it is not compulsory for us to design open structures. And it's not compulsory for us to design all our corridors to be open corridors. Right? This is purely a prescription. So what purpose would it be then for us to go through the effort to design the corridor and then we call it as an open corridor? What purpose would it be? What privilege is there for us to want to design an open structure in the first place? Okay, this is where we comes into looking back at the 10 schedule. It is all related to the mitigation of the risk. What is the risk of a building? We all know definitely if a building is an open structure or the corridor is an open corridor, you have far less risk of a fire building up and for the space to be rendered untenable in the event of a fire and smoke built up. Right, you can see from the first two videos that we've seen, if you got the room fully enclosed and if there are no sprinklers and no active smoke control, the smoke built up is extremely fast and the conditions become untenable in a very, very short time. Whereas if you introduce sprinklers, you'll find that the condition, generally untenable condition, may not arise at all, if the sprinklers are active. And on the same token, if you have active smoke ventilation and smoke control in the area, the conditions may not be untenable at all because you already mitigated it with the active smoke control. So all this links back then to the provisions, or what we call the kickoff line, for us to have to then apply or install active provisions. Okay, if you look at open structure, in a factory, if you design a single-story factory, say single-story detached or terrace units, basically single-story, you'll find that, look, once a building reaches, once that single-story factory that you're designing is more than 2,000 square meters, you will require sprinklers. Okay. In addition to the manual alarms, not too difficult, the fire control, rooms, things like that. So see, the kickoff is like 2,000. You design a single-story building. Once it's a single-story factory, once it's more than 2,000 square meters, this will be the biggest ticket. You need sprinklers. Okay, but if you're designing as an open structure, if it's a steel or metal fabrication works, engineering or metal workshops, or similar low-risk, fire low-risk establishments, open structure design in any size, there's no prescription for any active installations whatsoever. Just by being able to comply with this open structure design. All right. If it's an open structure design with a slightly higher occupational risk, like sawmills, steel mills, and all that, you need your hose reels, and you only need a pressurized fire hydrant. Item D only. Right? Still no sprinklers, regardless of size. Now this is a very, very clear, obvious thing, but only applies to factories. What about other building types? Storage in general, warehouses, logistics centers, automated storage facilities, car parks. Car parks, open structure car parks above ground, single story or less than 750 square meters. Again, absolutely no prescription for the requirement of installing any active systems. 2 stories and above, or more than 750 square meters per floor. Basically, this is 2 stories and above, that's it. In an open structure, you can build, if ever you do decide to build a 20-story car park, I don't think we'll ever want to do that, but what the bylaw actually does is that, go ahead, if you are the architect, we think that we can reasonably design a 20-story car park that's actually practical and usable, go ahead, because there's no more limits. And you don't need sprinklers at all. All you need is just basic hose reel installation and a manual alarm system, provided it's an open structure. Right? So to comply with open structure. If you don't comply as an open structure, then what will we be referring to? We'll just be referring to any other design, as per underground car parks, for example, or as an automated multi-level car park. So anything that's not an open structure, you have to then refer to this. And here it says anything more than 2,000 square meters, you need sprinklers. And you need the full complement of the detection, the CMS, and the FCC, and public address systems and all that. Okay? So that's the difference. So would it make sense for us to actually want to put in our effort to ensure that our car park, first, we want to design it as an open structure, and then we have to design it in a manner that will allow it to be classified as an open structure? I would say, yeah, definitely, because it's really not only about the cost, it's really just recognizing that an open structure for all intents and purposes does help to mitigate a lot of the risk. Okay, let's look at other building types. Institutional. Institutional applies to schools, hospitals, whatever. Yeah. Or in this case, let's look at educational occupancies. Open corridor design, 6 stories and above. Basically everything else lah. Yeah, just basic hose-free installations. No sprinklers required. 6 stories and above. You can design a super high, tall school building, and minimum requirement is only hose reels. If you don't comply to the open corridor design, that means you have to then refer to other designs. So other designs, anything exceeding 2,000 square meters per floor, exceeding 2,000 square meters per floor or more than 30 meters in height, you will need sprinklers already, and the full complement again of the detection and the automated systems over here. All right. Now, if you look at hotels, yeah, this is probably where it really comes in. Under an open corridor design, where the sprinklers come in, is that when you reach 50 rooms per block, 6 to 10 stories, when you have more than 50 rooms per block, or anything more than 11 stories, you'll need sprinklers. For the open corridor design, that is, sprinklers will kick in when you have more than 50 rooms per floor, or your hotel building is more than 11 stories or more. Right? If you don't design it as an open corridor design, you'll find that in terms of the hose-free installation comes in at 21 rooms, and you require sprinklers when you're more than 4 stories, irregardless of the, more than 50 rooms. And if you're more than 4 stories or your building exceeds 80 meters, you really require sprinklers. As compared to, if you design it as an open corridor design, you can go up to 10 stories before the requirement of sprinklers come in. Now, I'm not saying that we do this just for the sake of not installing sprinklers. As the video has already shown earlier, if we have the means to install sprinklers, by all means install it, because the sprinklers is really like the one single highest value of an active intervention system that you can install. It's got the greatest value. Install a sprinkler, is immediately there to activate in case of any fire whatsoever, and it does totally mitigate the risk of flashover and untenable conditions, right? But however, if you're designing for efficiency, designing for a good return on investment ratios and things like that, it is good to recognize this, right? That if you just take the trouble to make it into an open corridor, we will be helping ourselves a lot by mitigating the risk, and to, in a way, help to avoid having to install sprinklers when we don't need to install sprinklers. Yeah, so it is not about cost saving. It is really just recognizing what are the level of risk and what are the levels of mitigation that's available for us in the bylaws. Yeah, likewise, apartments and flats, find the open corridor design. Apartments exceeding 10 stories or 30 meters, basically any apartment of any size, any height. You don't go beyond just having a manual alarm, right? But once you have an internal staircase or core design, that means no more open corridors. Yes, it's still not requiring sprinklers yet, as far as UBBL 2012 lah. We have just finished off the UBBL 2021 has just been gazetted already. So these elements have been refine a little bit more already, but that's a different story. For now, let's just stick to this. You'll find that if you do not have an open corridor design, then you will need a full complement of the automatic detection systems and a full fire command center, yeah, for your apartment building, if you do not qualify as an open corridor design. Okay, fairly minimal when it comes to apartments, but yeah, these are the things to take note of. Okay, then that one brings us to smoke control. Okay, brings us to this thing about smoke control now. Okay, just give me a second. Okay, there are some questions coming in. Good. Okay, we will take care of keep the questions coming in. We'll take care of it at the end of the session. Right, now let's look at smoke control. What are the requirements of smoke control? In the UBL 2012 clause 251, it just says that smoke control systems, where specified, shall be designed and installed in accordance to MS 1780. Where specified, smoke control is not exactly specified in the 10 schedule, right? If you look at the 10 schedule, 10 schedule specifies hose reels, sprinklers, gas extinguishers, pressurized hydrants. Nowhere does smoke control comes in under the 10 schedule. But however, smoke control is defined and made as a standard in MS 1780. So MS UBBL 2012 just refers us to MS 1780. And this is where it says MS 1780 2017 applications. Basement smoke control systems. Smoke vents for areas below 1,000 square meters. And smoke control systems for areas exceeding 1,000 square meters for basement smoke control systems. Right. So basically what it means is that when you're in the basement, you will need smoke control. If the areas are below 1,000 square meters, you may use natural smoke vents for that purpose. Anything beyond that, you'll have to do your calculations and your engineering for the active smoke control system. An active smoke control system may also be naturally induced, right? But you have to support it with the calculations, etc., etc. And how do you get away from these? If your basement can be made as an open structure, yeah, that means you have open cuts on all round, and you make your basement as to comply as an open structure. All right, then they will be referring to a smoke vent or a smoke control system via natural means. You just have to prove it, yeah, when you come to your design. For areas exceeding 1,000 square meters or volume exceeding 7,000 cubic meters. So it is controlled by floor area or volume, whichever is the higher. Right? Once you reach 1,000 square meters in floor area, you will need a smoke control system of some sort, or if your volume exceeds 7,000 cubic meters. Smoke control of hotel gas room corridors. Okay, where internal gas room corridors are not mechanically pressurized, such corridors shall be smoke purged or diluted at the rate of no less than 10 air change per hour. Natural ventilation is permissible only if induced cross ventilation is available. So this is where, again, the open corridor thing comes in. All internal gas room corridors shall be mechanically pressurized, or you have a smoke control system in one way or another where the smoke can be purged or diluted at no less than 10 air change per hour. Right? Once you have 10 air change per hour, that means it has to be something that's mechanically induced or mechanically extracted to be able to quantify this minimum 10 air change per hour in the event of a fire. Natural ventilation is permissible only if induced cross ventilation is available. This is where you dial it into your design of your open corridor for the cross ventilation. And if you have mechanical inducement via either forcing air in, or actually the more effective way is to extract the smoke from one end, then you allow natural air to flow in via the openings that you created in your natural in your open corridor. Right. So these ones you work it with your engineers together in terms of the system. But generally what it means is that if you design open corridors and it complies with the openings and the cross ventilation requirements, you'll find that, yeah, it would do for smoke control. Protection of stairs and lobbies. Smoke lobbies, protected lobbies, ventilation of stairs, firefighting lobbies, etc. Okay, protection of stairs and lobbies. These are the very, very basic provisions in the bylaw when we do our design. It's important because once we start designing as the architects, once we start designing, whether where we position the stairs, how we position the firefighting access lifts and all that, firefighting access lobbies and firemen's lift and all that comes fully into play. Once we start designing that, that becomes the core of our building. So we have to get that right from the first day. The prescriptions are such that a protected lobby is a lobby separated or isolated from fire and smoke infiltration. That means it's a lobby which is protected, deliberately designed to protect it against the possibility of fire or smoke infiltration into the lobby. And that's called a protected lobby. A smoke lobby is similar to a protected lobby, but it is really primarily to isolate staircases from smoke infiltration, as opposed to a protected lobby, where this one refers to a protected structure, i.e. fire-rated compartmentation. A smoke lobby is primarily to isolate staircases from smoke infiltration. A ventilated lobby is either a protected lobby or a smoke lobby that gets its means of ventilation via natural means, ventilated from the outside. Okay, that's called a ventilated lobby. So ventilated lobby is not that the UBBL will not prescribe that you will require a ventilated lobby here or that. No, the UBL prescribes when you need a protected lobby, when you need a smoke lobby. Right? For us to design, how do we make the lobby as a protected lobby, or how do we make the smoke lobby as a smoke lobby? This is where we can do it via ventilated means, natural ventilated means, and that then becomes a ventilated lobby. And a firefighting access lobby is a protected lobby. First and foremost, it is a protected lobby, which is designed specifically for firefighting access, right? That would be called a firefighting access lobby. So the protected lobby and the smoke lobby are the two requirements. Ventilated lobby is only referring to the means, one of the means of your designing for the lobby, for it to be protected or for it to be a smoke lobby. And a firefighting access lobby is a specific requirement, right? That has to be of a protected nature, which can also be protected via as a ventilated lobby, right? That's a firefighting access lobby. Okay, protected lobby requirement for buildings. Okay, first requirement will be anything above 18 meters. You will find that this 80 meters here corresponds to your requirement for the installation of risers, which also corresponds to the requirement for the firefighting access lobbies, which then also corresponds to your requirement for your fireman's lift and the firefighting staircase. In other words, the 18 meters height, building height, is the kickoff point for us to install the firefighting shaft, the vertical firefighting shaft for internal firefighting. 18 meters. Just kicks it off everything from there. So the protected lobby requirement also kicks off at 18 meters to correspond with all of that. So you have an internal core here or a staircase here. Once it reaches 80 meters, you'll need a protected lobby requirement here. For stairs that are opening straight onto the outside, that means this shaft is a fully naturally ventilated shaft, then you do not need a protected lobby. Right? As long as that stair, that protected shaft, is fully naturally ventilated on the outside, then you do not require a protected lobby. Next level up. If your building is below 45 meters, right, just now here, okay, once it's above 80 meters, you require a protected lobby. Right, up to 45 meters, 80 meters and up to 45 meters, this protected lobby may be replaced by purely pressurizing the shaft. Right, so you do not require a protected lobby if you have actually just pressurized the shaft for buildings below 45 meters. Right, mechanical pressurization. And then for the stairs that's open to the external, naturally ventilated, okay, nothing happens because you can get away with it. You still don't require any further protection. And if you go beyond 45 meters, for buildings beyond 45 meters, you must have a protected lobby, right? And the protected lobby must be protected via pressurization. And again, for the stair that is naturally open to the outside, that gets full natural ventilation, you don't need anything else. That one can stay as it is. So the summary is that if above 80 meters, your shaft, internal shafts will need protection. If it's shaft that can get full natural ventilation over the entire height, yeah, that's the protection. If it's the internal shaft that doesn't have natural ventilation, then you need the protection of either either a protected lobby, or you actually have to pressurize the shaft. If it is above 45 meters, you can't just pressurize the shaft, you must have the lobby, and the lobby itself must also be protected by pressurization. Okay, that is just the bar. But if the shaft is naturally ventilated, see, nothing happens over the entire height. You can actually build a building 100 meters, 200 meters, super tall skyscrapers. If you have a shaft that's actually open to the outside, you don't need any protection per se. Right. So that's one. This one again tells us of the importance of natural ventilation. Open corridor, open stairs, and all that. Really, if you can just open up to the atmosphere, we have taken away a huge chunk of the risk of fire. Okay, now let's look at firefighting, access, and rescue. Let me just look at some of the questions first to see if there's anything that I will need to come back to. Okay, that's good. Okay, we can cover the questions. We can cover the questions later at the end of the session. Yeah. Okay, firefighting, access. All the various clauses are here. I'll show you another video. This video is of downtown fire in Paris. It's a fire burning from one of the boulangeries downstairs, and upstairs it looks like either an office or a apartment block. It's got a single stair, and typical Paris roads are very narrow. So yeah, let's just have a look at this video.
Right early, fleet.
The fire is from the boulangerie downstairs.
Get the cops over here.
This one appears to be like the common staircase that's going up to there. The fire seems to have gone into the stairs. Not the fire, sorry. The smoke has infiltrated the stairs. So these poor guys are basically just hanging off the balcony to try and breathe because they can't walk down the stairs anymore. The stairs is filled up with hot smoke. So there's nowhere to go. They can't go back to the stairs, go back down, to go downstairs. They can only hang themselves out from the balcony. Because the firemen can't get into the building. This is not a high-rise building, neither is it a modern building. So obviously there are no there are no firefighting shafts in there. Definitely there are no firefighting shafts in there. And there are no sprinklers in the building, obviously. So firemen are just doing the very, very traditional rescue by attempting to rescue the people from the outside with the ladders and the turntable ladders. So there's no chance of the firemen fighting the fire from the outside in this situation. They just are taking the people out from the outside. Look at the effect of the fire from down here. I just pause it a little bit. So look at the effect of the fire from below here. Oops. Okay. The fire is actually burning down here, so the fire is leaping up. Right, so the hot plumes of very, very hot gas is actually moving upwards over here along the wall. And that is immediately above is where they're trying to rescue the people. Just look at the conditions of which the of how they're trying. These are all the extremely hot smoke that's coming particularly straight up here, from here. It's going all the way up. While the rescue operation is going on, the firemen below are trying to cool down the fire by putting water into the fire. Just pause here for a short moment. You look at the situation in which the firemen are working under. This is existing. These are obviously a very old part of Paris. I do not know the actual width of this lane over here, but just estimating from the width of the truck and all that, I reckon this is about just barely 6 meters from the scaling of this from this video. So a fire is burning very, very heavy down here. People are trapped up there because the smoke has infiltrated into the staircases, and the firemen are trying to rescue the people. They have to park the fire engine over here. This one got a turntable ladder for them to reach the upper part of the building where there are still some people trapped up there, as you can see. So the fire engine here, this is a turntable ladder. So when the turntable ladder comes here, you see that the turntable ladder have to extend its booms. It's the arms, right? So it have to extend its arm to stabilize itself. And there's another few fire engines over here. You saw the firemen bringing the fire hose, running with the fire hose to try and make the connections to the hydrants, right? So the firemen are down here trying to cool down the fire in the shop, and these people are trying to do the rescue using a portable ladder. And that fire tender over there with the ladder is trying to do the rescue of people at the higher floor. That's a turntable ladder that is trying to reach these guys. The smoke and the effect is taking up more than half the lane already. Just observe again from this view the position of the ladder. Okay, look at this view here. The kind of activity that's going on at the ground level. Again, I was estimating that the total width between the building to building is probably about 6 meters. The actual driveway after the aprons and the curbs is probably about 4.5 meters, just based on the scale of the fire engine that was parked over there. Look at the kind of activity that's going on over here. The spaghetti arrangement of all the firefighting hoses connecting to the hydrants, to the fire tenders and all that.
Well, nobody died apparently. We were very lucky. No one died.
And the fireman's up there now, trying to cool down the fire from the roof. Well, nobody died in this. Nobody had severe injuries or death in this incident, so we're all very thankful for that. I just look again at the kind of activity and look at all this debris. There are lots of debris falling from the upper part, from the smoke and from the consumption, the burning of the awnings, the burning of the canopies and the awnings from the boulangerie downstairs. Right? Yeah. Okay. So this is the situation. Okay. Okay, now let's go on to firefighting and rescue. I'll come back to this video later. The Bomba Johor factory fire. I'll come back to this a bit later. Okay, fire appliance access. Clause 140. 140 has been amended from the earlier clause 140. Introduced a lot of new things now. In particular, now fire appliance access is known as the access way. Okay, we are all very familiar with this now. Access way, minimum width of 6 meters. Minimum, I have to always stress this. It is not access way shall be 6 meters wide. No, access way is the minimum width of 6 meters. It cannot be less than 6 meters, but it is no way specified the access way shall be 6 meters. No, it's just a minimum width of 6 meters. And access way shall be positioned so that the nearer edge shall not be less than 2 meters from the center position of the access opening. And also, it cannot be positioned in a manner that the nearer edge is more than 10 meters. So in other words, the nearer edge of the access way cannot be less than 2 meters, and also it cannot be more than 10 meters from the center position of the access opening measured horizontally, i.e. to the face of the wall or face of the building, where you have your access openings. And the access way shall be laid on the level platform, or we can tolerate an incline of not exceeding 1/15. This is not to be confused with that of an access road. Access road, on the other hand, shall not exceed the gradient of 1/9. Right, that would be for the access road. Access way, okay, then the dead end overhead clearance shall not be more than 4.5 meters, etc. So all these are quite self-explanatory. Oops, where am I? What happened? Okay, then and 197A, the designing of access way shall be read in conjunction, really, with the requirements of means of firefighting for buildings over 18 meters. We know any building over 18 meters, you kick in the requirement of the firefighting shafts, which means the firefighting access lobbies. Fireman's lift, firefighting access lobbies, fireman's staircase, and most importantly, the installation of the risers. We call it the internal hydrants. And fire appliance access way, as a definition, is an area for the entry, maneuvering, and parking of fire appliances during firefighting and rescue operations. That is an access way. When we require an access way, this is what it means. I will term the access way as really the car park for fire appliances. Right? When we design a car park, what are we designing for? We demarcate the car parking base, right? But we also have to design the entire driveway, the ramps, the maneuvering, and all those things to get the cars to be able to enter the car parking bay where they actually park. So I take the access way as the car parking bay, right? And everything that you have to do to lead you or to lead the fire appliances to the access way shall be known as the access roads. Access road is a road capable of accommodating the passage of fire appliances to enter an access way. And access openings in this case refers to doorways or openings that allow fast and safe entry of firefighting and rescue personnel into the building. Basically, all the doors that you allow the firemen to enter. And almost always the front entry door would be considered an access opening. All the escape or all the final exit doorways can be access openings. And the firemen may require further additional demarcated access openings to be made into the building. Yeah, I'll go into that a little bit later. All right, let's look at the external access. Access for emergency and rescue vehicles, equipment and road personnel, roads, pavements, parking, and most importantly, the availability of water in the form of hydrants, storage tanks, lakes, rivers, etc., etc., and access to firefighting systems in the premises. And when the fireman arrives at the premises, the clarity of the type of building and function, configuration, location of fire control panel, location of breaching inlets, and all that must be very clear, or at least be visible to the firemen. And access into the building via protected passages, protected stairs, fireman's lift, firefighting lobbies, all those things. Look at the access systems that are available on the site first. Let's look at pressurized hydrant systems. This is primarily installed in usually factories and industrial, standalone industrial complexes. We have the hydrants, then we have the storage tanks for the stored water, the initial water to feed the systems. We need the pumps, of course, for it to be pressurized to get the water from the tanks into the system, and we need the breaching inlets. Right? There's a breaching inlet over there. Look at sprinkler system. Much the same. You got the sprinkler system. These are the actual sprinkler outlets. You need a storage tank, the big tank for the initial water, the bulk water for the sprinkler system. You need the pumps for, obviously, to get the water into the sprinklers, to pressurize it, to get it into the right flow. And we have a breaching inlet in the system. A dry riser system, dry riser by virtue of it being dry, that means it doesn't have its own storage tanks, and no storage tanks, no water, no pumps. Yeah, but yeah, at least got the breaching inlet, right, for you to be able to connect water into the system. Then the wet riser system. So wet riser is exactly the same as the dry riser, except that because it's wet, so therefore it's got its own tanks. And with the tanks comes with its pumps, and there's a breaching inlet over there. So how it all comes in together is very simple. We have a building here. These represents all the internal systems. The internal systems will be sprinklers, the risers, and the hose fields. But the hose fields is really meant for first aid. So tanks, pumps, and then to the outlets apply for the sprinklers, the hose fields, and the risers. That much is much the same. For the breaching inlet, for the tanks to be connected to the outside, only the sprinkler tanks and the riser tanks are connected, have this breaching inlet. Now, hose fields, you don't need breaching inlets for the hose fields. Basically, if the water runs out, it runs out. It's for first aid. If you actually use up all the water, good. Fire should have been put out, or it should be out of the building. Right? But whereas the breaching inlets is required for the sprinkler systems and the riser systems. And outside, you got the access way, and then there'll be external source of water, primarily the hydrants. And if you're away from an urban built-up area, you may be relying on natural bodies of water like lakes, ponds, pools, or rivers. Yeah, on rural applications are where you do not have access to specific hydrants, right? But you need an external source of water at hydrants. Then that's where the access way comes in. Access way is between like a go-between for between the external source of water and the internal firefighting systems. So if there's a fire, so if there's a fire here, depending again on the installation of the systems in the building, if the building have got hose fields, the occupants of the building may use the hose fields to attempt to fight the fire. It's the first aid, so they're activated, and the pumps will start going, the water will be fed, or the sprinklers may be activated if there's sprinklers. Yeah, but you will not be touching the risers, of course, because nobody will touch the risers. Okay, sprinklers will activate automatically where it's installed. Hose reels, if the occupants want to help themselves, they may do so, right? But that's where the internal systems start to come on. First aid, immediately it comes on with a fire. And when the fire engine eventually arrives, if the fire engine, when they arrive, all fire engines do carry a certain amount of water, but really the fire engine, for all intents and purposes, is a giant water pump. It's a giant mobile water pump. That's what the fire engine is. That's the primary purpose of the fire engine. It is a giant mobile water pump. Okay, so when it arrives on the scene, if it's obvious that they have to do something on the outside, by either cooling down the fire, or they try to mitigate the fire and all that by spraying it, okay, they may be able to activate it straight away. But that would really not be the immediate action by the firemen. What the firemen would really want to do when they arrive is that they have to strategically park the fire appliance in a safe distance, in a strategic location, because the whole purpose is that they want to connect the fire engine to the external source of water. They want to connect the fire engine to the hydrants, and then from the fire engine to the hydrants, with the pumps running, they'll be able to then shoot the water from the fire engine. And if the building is equipped with internal systems, like a high-rise building, you've got a firefighting access lobbies and all that, what the fireman wants to do is to be able to connect the fire appliance or the fire engine, connect the water supply from the hydrant through its pumps, for them to then feed it in through the breaching inlet. Right, so that the water source to the sprinklers will continue to be replenished. If there are no sprinklers, then they want to ensure the water gets into the risers. If it's a dry riser, they have to do that immediately. Right? If it's a wet riser, yeah, one set of firemen can actually start to go in already, because the wet riser will already have a source of water immediately for them to be able to use. But the second team will have to be there to connect the hydrant via the fire engine to the breaching inlet, so that they'll have the assurance of the continuous stream of water into the system. Right? So this is the diagram, very, very simplified, but in essence, this one shows what's the relationship between the hydrants, the fireman's appliance, and the breaching inlets and all the internal water systems. Really, this is very, very simple. But this is a diagram that all of us should understand in how we're doing it. So the accessway, as you can see from the video earlier, the accessway is really the place where a lot of activity happens. You have to park a fire engine for rescue purposes. That's also where you park your turntable ladders. Firemen are running everywhere, and there'll be a lot of hoses running everywhere, because they have to connect that to that, to connect that to that. If that one is not available, they have to connect that to that, and then they have to have enough units of this to start to be able to shoot water from the outside, etc., etc. Right? So the importance of accessway is very, very important, and the relationship on how you place the accessway is this. We have to be able to connect hydrants to the fire appliances to the breaching inlets, or to access the immediate facade of the building for us to, for the where we required portion of the building fronting the accessway. Right? If this is the required portion fronting the accessway, like say for example, this building requires 1/4 of the frontage, so that would then be the accessway. That would be the required length for you to front the building, and this will then be the facade of which is fronting the accessway. So the accessway, minimum 6 meters width, absolute minimum. Please make it as wide as you can, but absolute minimum. Minimum 30 tons load, gradient not steeper than 1:1.5, and no overhead obstructions whatsoever for an accessway. No overhead obstructions. And access road minimum width, I'm suggesting at least 4.5. But of course, access road is literally anything. Any way in which you can get a fireman into the accessway will be fine. But firemen do have to drive very, very fast. So the last thing they want to do is slowed down by a very narrow road or very high curbs and all that, where they have to slow down and try to maneuver the vehicles in. Right? Just make things wide and clear so that the firemen can arrive at the accessway in the shortest possible time. Gradient, no more than 1:9. Minimum overhead clearances. For access roads, yeah, you can cross through gateways, overhead pedestrian bridges, overhead cables and wires and things like that. Just ensure that the path that you're designing for firemen to enter to get to the accessway, overhead clearances shall not be less than 4.5 meters. Very important. Sometimes they miss it. Things like even a single stray overhead telephone cable or overhead power cable, one-phase power cable, someone just did an extension. Those things can be very, very dangerous. We just don't notice it. So it is very important for us to keep a clear eye out for these overhead clearances. And then access opening to be located fronting the accessway. You must have access openings fronting the accessway. And width of the access opening, well, if the access opening is designed for as a final exit, whatever width it is that you're designing to accommodate the occupant load for exit purposes, yeah, so be it, because accessway is really access opening for all intents and purposes, just the same opening for your exit into the building. Firemen will use that to enter the building. And the edge of the accessway, right, the physical edge or a demarcated edge from which you start the measurement of the width of the accessway shall not be less than 2 meters to the face of the access opening, and it cannot be more than 10 meters away from the face of the opening. And if you require another portion of the building to have front an accessway, like in this example over here, okay, then you repeat the same thing to wherever the portion, and connecting the accessways shall then be the access road again. Right? So these will be the required accessways, and all these will be access roads to connect the accessways. So the access roads need not be designed as an accessway if it's not required, right? But the accessway that's required will have to be designed as an accessway. Right? Again, it's a bit like the car park arrangement. Car parking bays have a minimum size and dimensions. So where you demarcate the car parking bay is where you mark the car park and say that's a car park. Then you have to design access roads, ramps, and everything else to bring the vehicles to the car park. Yeah, that's exactly the same concept. A bit more details on this. When you arrive at the scene, in terms of the physical building design, the accessway will be there. So therefore, what are the other immediate things that will be required to be accessible from the accessway? Because the accessway, as we know, is a place for the parking of fire appliances and for the firemen to conduct their the staging and all the necessary activities for them in fighting the fire. So the more complicated the building, the more things there are to coordinate. In the building where you have a requirement for the firefighting shaft, naturally you already have the pumps, the tanks, right, for all your internal systems. So that's where the breaching inlets come in. The requirement is that the breaching inlets shall not be more than 30 meters away from the nearest hydrant. There are hydrants everywhere, but there has to be at least one hydrant no more than 30 meters away from the breaching inlet. And hydrants to hydrants, of course, we know is not more than 90 meters. And there must be an access opening fronting the accessway. And then there'll be the firefighting shaft. Right, so this relationship is very, very important. This will be the barest minimum of a relationship between the external hydrants and the internal systems. Let's recap in terms of the designing for the firefighting accessway. We know it's by volume. Any buildings above 7,000 cubic meters to 28,000, 1/6 of the perimeter of the building shall be the minimum dimension. The minimum dimension of the accessway shall be no less than 1/6 of the building once your building volume exceeds 7,000 cubic meters, and so on and so forth. We'll find that you reach an island access, so means your whole building, the full perimeter will have to be accessed by an accessway once you reach 112,000 cubic meters and above the island site. So our local UBBL, when it comes to accessway, we are still referring solely to the building volume. We have not made any concessions yet at this point in time with regards to the proportions of the building. We're just going solely by the building volume. Right, what I'm going to show you next is purely an illustration on what that one actually means. And by our understanding of it, how do we then apply our full architectural design prowess to ensure that our provisions and our design of an accessway meets the actual practical requirements of an accessway. Okay, let's look at this example here. These are building volumes. Let's just say 30 meters by 30 by 30. So that's 27,000 cubic meters. So according to the chart, we require 1/6 of the perimeter to be fronting the accessway. So that's the 1/6 of the perimeter. Right? The yellow is the accessway. Access road leading to an accessway. So the required accessway will be this proportion over here, this little 1/6 over here, right? 1/6. If you have to double the building to 60 meters high, so that's double the volume. This building is now double the volume of that example. The bylaw says we need 1/4 of the perimeter to be accessway. So, okay, if this is 1/6, this is a square plan. So 1/4 is this extra little bit over here. So, okay, so the accessway minimum requirement is now 1/4 of the perimeter over there. Okay, let's go bigger. So we increase the volume of the building again by another proportion. So now 90 meters high, and now we need half of the perimeter of the building to be fronted by an accessway. Okay, so that's half. So now the accessway is this way. It's L-shaped now because it's fronting half of the perimeter of the building. Let's go a bit higher. 120 meters high now. Oh, now you're reaching super tall skyscraper already. 3/4 of the perimeter of the building. 3/4, what do we do? Okay, that's the 3/4. So you can see that there's now the building, by virtue of its increased volume, not the increase in height, because our UBBL only looks at the volume. So by virtue of the increase in volume, now the accessway has to go around 3/4 of the building. Then, if we go even higher, 150 meters high, we are now 135,000 cubic meters. So this becomes an island site. So what do? There you go. All right, so now there's an island site. Now, if you analyze this situation, if you do the accessway in the manner that we've shown over here, and if that's the building that you're designing, yeah, this one actually complies with the basic requirements of the UBBL. You can't dispute that. But if you look at exactly what is the purpose of an accessway, we will find that by doing this, we may not exactly be fulfilling the actual practical requirements of an accessway. Not to say we're not fulfilling it, but we may not actually be designing in the most efficient manner for it to fully function as an accessway. Take the example of this building. This building is 30 meters high, so there's about 8 to 10 floors at most. Fairly low-rise building, and it's buildings like this that firemen would be fighting the fire from the outside. No doubt, 30 meters high, you already got the internal risers, but if there's a fire breaking out from the outside, firemen need to park on the outside. And like the example we saw just now, there may be situations where firemen need to rescue people from the outside, etc. So if the fire burns on that part of the building, which is not covered by the accessway, obviously then the firefighting, activities may not necessarily work for a fire that's breaking out on that side of the building. Firemen will actually still have to enter the building and then try and sort out the things from the inside using the internal risers. Then on a building like this, you've got the requirement is a full island access. So okay, a same fire breaks out on exactly the same location in plan. but it breaks out on the uppermost floor. Would that access way in any way help the firemen to fight the fire from the outside? The answer is definitely no, because in a situation like this, the firemen would be using the internal systems already, the risers in order to fight the fire from the inside. So what I'm saying is this, our current bylaw just go by volume. It's because it's prescriptive. So yeah, we do have to at least comply with the minimum requirements, but it may not necessarily be fulfilling, or it may not necessarily be the most efficient way of doing it, or the most appropriate way of doing it. Just give you another example, using exactly the same analogy. We have say a building like this. This is the analogy of us going up. So there's a 1/6 of the perimeter, and this one is 1/4 of the perimeter. If we put the building down low rise like this, the building is long, and this one got exactly the same volume as that building. This one also requires 1/6. So the 1/6 is obviously longer because there's more perimeter, but you can fulfill the 1/6 by doing that. And for a building of this volume, if you stacked up high, you've got half the perimeter access over here. But for this building, if you stack it up that way, this building has got the same volume as that, and the requirement for perimeter access remains at 1/4. So what is 1/4? It is just that. Right, so you've got a building that long, by prescription, by doing the perimeter access at 1/4 just surrounding here, you've met that requirement. But if a fire is to burn out at that corner, you'll find that the fireman is really too far to access it. And worse, at least with a high rise, we have the internal firefighting shafts. So firemen are able to go in there. There are internal risers, firemen's fight, the bombard lifts and the firefighting access lobbies and all that for firemen to fight the fire from the inside. For a building like this is low rise, there are no internal hydrants. There are no internal firefighting shafts. All you have are hose reels in there and probably sprinklers. For firemen, they park the fire engines over here. They can't reach that space. No doubt you have complied to the bare minimum, 1/4 of the perimeter to have a fire appliance access. Yeah? So just minimum prescriptive compliances does not necessarily mean performance compliance. Just remember that, because it's very important when we design our buildings. We have to recognize that. Yeah, just some scenarios in terms of the differences between the amount of space a fireman will need, low building versus high building. Low building, with a low building, look at the angle required for the fireman to reach the top floor. The examples shown just now in the video in the Paris fire, right, as opposed to that, how much space you require. Okay, now let me just introduce you very quickly to the Singapore Fire Code. I'm not saying that we want to impose a Singapore Fire Code, but just reading it, you'll help us to understand a little bit more. Singapore Fire Code, in terms of the fire appliance access, they've got the requirement, they've got the prescriptions based on volume of building, but for certain building types, they've also got the requirements based on the floor plate surface area. A proportion of perimeter access determined by floor plate area instead of solely by the volume of the building. For example, in this one here, this is for buildings in purpose groups 3, 4, 5, and 7, exceeding the habitable height of 10 meters. The access way is no longer just based on the volume of the building, but it's also on the floor plate. So like for example here, a floor plate of 4,000 to 8,000 square meters, you require half the perimeter for the fire appliance access. This is Singapore Building Code. I'm just using this as an illustration for us to understand. So in a scenario just now when I was mentioning, if there's a fire over there, if you're using our by building volume, this is the only this is the minimum perimeter access that will comply with the bylaw. You design it this way, Bomba will have to give you approval, unless they come in here and study it further and say they impose you to do something else. But this one complies with the bare basic prescriptions of the bylaw, right, by volume. But if you look at the Singapore code, okay, if you look at the Singapore code by floor area, 30 meters by 180 meters, 5,400 square meters. Right? If you go by building volume, 54,000 cubic meters, we require only 1/4 of the perimeter for the fire appliance access. But if you go by volume, same building configuration, you require half. And half means we will have to do that. That is half. Right? So this one then gives a far more practical frontage of access ways relative to the shape and size and configuration of the building. And in recognition also that the building of this nature may not necessarily be equipped with internal firefighting shafts. Right? So you do have to fight the fire from the outside in a lot of cases. See the big difference between that and that. Right? This is just one illustration. You'll find that different buildings have got so many different configurations. So what I'm really saying here is this: we now understand the basic purpose and the basic requirements that led to the minimum prescriptions that we've enshrined into our local bylaw. So when we design a building, rather than just aiming for the absolute minimum prescriptive compliance with the bylaw, with our understanding, we are in a far better position to be able to design the building to be even safer for our local Bomba guys to help us in the event of a fire. And this one helps us a lot in our liaison with Bomba. Very often we hear of people saying, oh, we want Bomba to waive this requirement, we want Bomba to waive that requirement because we think this is excessive or what. But really, I think the whole intention is not for us to want to ask Bomba for us to waive this or to waive that, but it is for us to go to Bomba and say, hey, look, now this is the way we're designing the building. Our configuration is unique in this particular situation. In this situation, just complying with the minimum bylaw does not quite work in that direction. Instead, let me compensate it for you by doing something greater over here to allow you to fight the fire from here. All right, so we are then now in a far better position to be able to genuinely offer what is our firefighting concept that is unique to our building that we are designing. Yeah, so I hope this one helps to bring clarity to our bylaws and our prescription. So applying performance criterion to check our prescriptive codes can often lead to far better design. And Bomba will really appreciate you for this, because we are going over and beyond just mere compliances with the minimum prescriptions. We are actually looking actively out for ways to make things a lot safer. And it is with all this work over here that we can accumulate, put together, consolidate it, and this becomes the advancement. And yeah, hopefully these things, once we have studied and we understood it, it can then be the new incorporated into the new revisions of the new bylaws in the near, not too distant future. Yeah? Because that's what our work is all about. It's all about continuous improvement over the years through our experience. All right. Okay, so last thing to cap it off on how we apply firefighting shafts, primarily for high-rise buildings. We know 18 meters is the cutoff, is the threshold. Once you cross 18 meters, the introduction of the firefighting shafts come in. It's not only the building height, it's also the building below the ground. The threshold of buildings below the ground requiring firefighting shafts is 9 meters. So remember, it's 18 meters above ground, 9 meters below ground. A building that's higher than 80 meters, you need a firefighting shaft all the way from the fire appliance access level to serve the topmost occupied floor. And for a building that is got a basement, but if the basement is not more than 9 meters down into the ground, you need protected stairs, protected shafts, protected access shafts for exits and also for fireman access, but you do not need to bring the facilities of the firefighting shaft down to the basement if it's less than 9 meters. If the building is shorter than 18 meters, but for some reason it's deeper than 9 meters below ground, then yeah, you do have to provide a firefighting access shaft, a firefighting shaft from the appliance access level down to the lowest level of the basement, right? But you do not need the firefighting access shaft to serve the upper floors if the upper floors are less than 18 meters from the fire appliance access level. And of course, if you've got a building that's taller than 80 meters and deeper than 9 meters, you will need a firefighting shaft to be all the way down. But they have to be a crossover between at the fire appliance access level, there must be 2 separate shafts, a crossover. We do not mix the same shaft together from the basement all the way to the top. Okay, there have to be a crossover here. And if you got different levels of fire appliance access level, say a half kind of a level, yeah, you will need things like that. Right, so the firefighting access level from there, there's a crossover here, interchange, sorry, I won't call it crossover, it's an interchange at the main fire appliance access level, one shaft to go up and the other shaft to go down. If you have 2 levels of firefighting access, right, then we can do it this way. Then that will become a single shaft because there's no below ground in this sense. The fire access, appliance access will be at 2 levels. Fire appliance access from that level and the fire appliance access from that level. Then this one can be one continuous single shaft to serve the entire length of the building. Right. So this definition will help us a lot, I think, for us to as a basic diagrammatic concept in how we configure our buildings. Evacuation of separate route. Okay, this is quite redundant. In terms of risers, just the location of risers, which is corresponding again with the location of the firefighting shaft. We have to refer to 2 different documents, both the UBBL and the Malaysian standards to correlate it. There are no contradictions. A lot of times when we read the different numbers, we find that even within the UBBL itself, it appears to contradict each other, but actually there are no contradictions. It is purely in what the particular clause is actually referring to. So for risers, UBBL 230 and 231, all parts of the floor must be within 45 meters from a landing valve. And the firefighting access lobbies, level distance from the furthermost point should not exceed 45 meters. So it appears a bit quite consistent here, but one is actually referring to the FFAL. The other one is referring to the riser landing valve. Right, so this one is radial distance from the point of the landing valve and from the point, which is the point of the entrance to the firefighting access lobby, the protected entry to the FFAL. Then the requirement for fire lift. Fire lift is not more than 61 meters travel distance from the furthermost point. And the firefighting shaft itself. So all these items are actually all together. You've got the risers. A riser is just a single pipe with a landing valve to be located within the firefighting access lobby. And a firefighting access lobby must be accessible to a fire lift. And all of these things here are actually located inside a single firefighting shaft. Right, so the location here, firefighting shaft, is under Malaysian Standards 1163. With a fire lift, a firefighting shaft with a fire lift, that is, must be no more than 61 meters from fire mains outlet, measured on the route in laying a hose. This fire mains outlet refers to the landing valve. Right? Fire mains outlet is actually referring to the landing valve up here. So, oh, there you go. Yikes. Is there a contradiction? And for a firefighting shaft that hasn't got a firefighting lift, okay, I know some of you are now asking already, but I thought you just said all firefighting access lobbies, firefighting shaft must have a fire lift. Okay, not quite. Let me describe it a bit later. So in a firefighting shaft that has not got a fire lift, then it should be located no more than 45 meters from a fire mains outlet, from a landing valve, measured in the route in laying a hose. Yikes. A lot of contradictions here? Not exactly, because this one is referring to radial distance. This one is referring to the actual route distance. That means you're going around corridors, you're entering rooms, etc. Yeah. So this one is about pulling a hose in the manner on how the hose can be pulled. This one is just a radial distance. This is a bit like an open plan radial distance. You get a radial 45-meter radius and you draw a circle to see if it works. So the way to check it and to apply will be like this. Let's take a hypothetical floor plan like this. There's a protected shaft over here, i.e. that one just contains a staircase. The full FFAL shaft is over here. Now, for purposes of this illustration, let's just say that the wet riser is located, the landing valve is located in that corner, just for this purpose of this illustration only. Don't take this plan as an example for any purpose other than just an illustration. And the fireman's lift is located over there. So if we look at how we go, so let's start checking. First, compliance, firefighting access lobby, not more than 45 meters radial distance. So that's the entrance door. Okay, this one complies. You know, all parts of the floor is within the 45 meters. Second check, the landing valve, risers, all parts of the floor within 45 meters radial distance from a landing valve. Oh, whoops, if we do this one, we find that this part of the floor does not comply. It's missing. Of course, you would be saying that, oh, it's very easy. All we have to do is move the riser across to this side and it will comply, right? Yeah, of course it does. We are just using this as an illustration, yeah, of what happens when this happens, right? But really, the easiest way to solve this one is move the riser to this side and then you will comply. Okay, but let's say that the situation is like this. So the next check would be this. We'll check it with the route distance. So we start here and we ask ourselves the question, is the fire lift within 65 meters of route distance from the furthermost point of the floor? Oops, sorry. Add a firefighting access lobby. Because that's really it. If the fire lift cannot be within 61 meters of a travel distance from any part of the floor, you need another firefighting access lobby. So if it's no, you have to add in a firefighting access lobby. If the answer, yeah, our fire lift is within 61 meters, so yes. So then the next question you have to ask, if the fire mains within 61 meters also, fire mains will be a different location from a fire lift. You don't install a fire mains exactly in a fire lift. You can't do that. So ask yourself again the question. If the answer is no, then you can install a fire mains in a secondary protected stair, which is within 45 meters. Right? So you don't have to add a firefighting access lobby. First, if the lift complies, then you don't need to add a firefighting access lobby. Then you look at the fire mains. If the fire mains doesn't comply, then you can add in a fire mains only in the secondary protected stair. So this secondary protected stair will be the secondary firefighting access lobby that will not have a fire lift. Right? But if the fire lift cannot cover the distance, then yes, you must have a second fire lift. And when you have a second fire lift, means you need a full-fledged firefighting access lobby. Right? So this is a very simple cross-check. Yeah? And of course, if all of these answers yes, eventually, If you install the fire mains here, yes, and yes, yeah, okay, then you're finished. Then you finish your design already. So there's no contradiction between the prescriptions in the UBBL and the prescriptions in the MS 1163 and in the fire lift, fire mains, and the firefighting access lobby. No contradictions. It is just this prescription only that we need to understand, right? Okay, I think we'll quickly wrap up now. In terms of the relationship between the external hydrants, the breaching inlet, and the internal accommodations and the internal shafts, generally this is what it is. Yellow is the access way. This is the near edge. The red line is the minimum 2 meters, maximum 10 meters from the access opening on this big black line over here, which is the wall of the building, and that's the accommodation inside the building. Minimum requirement, breaching inlet no more than 30 meters from the nearest hydrant, just one single nearest hydrant. And the fire appliance can only be parked on the access way. So it has to be in a position, the access way has to be configured in such that it shall not be more than 18 meters away from a breaching inlet. That means the nearest edge, no more than 18 meters away from a breaching inlet. The bomber, they can park no more than that, from breaching inlet, and the hydrant to the breaching inlet, no more than 30 meters. So just within this two configuration, you can do a lot of things. Where a building is equipped with a firefighting lobby, i.e. if there's a wet riser, then the relationship will be like this, where the fire truck shall be allowed to be parked in a position on the access way that he'll be no more than the fire appliance access will be no more than 45 meters away from the riser, from the landing valve, the first landing valve at the ground floor, no more than 45 meters away. And maximum 30 meters. Sorry, I'm going backwards. Oh, okay. And where a building has got no internal firefighting shafts, say it's a single-story building or a low-rise building, but very, very deep floors, the configuration shall be such. Access opening shall be located in a manner that you should be able to get maximum 40-meter direct distance, radial distance to any part of the accommodation, or maximum 60 meters route distance to any part of the accommodation. And again, the relationship between the access opening and the hydrant shall be this: maximum 80 meters to the nearest point in which the bomber can park, and maximum 30 meters. And wherever the bomber is parked in that position, bomber is within the appliance access, the fire engine is within 30 meters to the nearest hydrant. Right? So that's the general configuration. And if we wrap all of that up, we should be well on our way to the proper compliances with bomber. Yeah. Okay, I think I would stop here. Thank you very much. I'll hand it back to you, Justin.
Thank you, Architect Chong Lee Siong, for the very informative session. We'll now proceed to the Q&A session. There's quite a lot of Q&A in the tab.
Okay. Okay. I'm reading here. Are you guys able to see my my Q&A window? Yeah.
No.
No.
Yeah.
Okay. Never mind. Everyone's got access to the Q&A window, right?
No, I think only the panelists have access.
Oh, okay.
Yes,
then,
so they will only be able to see their respective questions.
Okay. There are two. Some of them went into the chat group. Then there's a Q&A. So some questions appeared in the chat group and some questions appeared in the Q&A.
Yes.
So okay, never mind. In that's the case, then I would just. How much time have we got?
I think we can allow maybe until 12:30 if everyone is okay.
12:30. Okay, everyone okay? Then I suppose best way would be go through the question one at a time.
Okay, we'll start with the Q&A tab, and then I've compiled the questions in the general chat. I'll pass to you through the message.
Okay.
Okay.
Okay. All right. Okay. So the Q. Let's see. Okay. So okay. So I'll start with the Q&A. So the Q&A, the first question. For open structure calculation, can an opening to air well deemed to be open to atmosphere? Yes, it is. That's exactly what I mean. That the air well has to be of the dimensions that is a permitted air well. You get the air well, the minimum air well dimensions in the UBBL itself under the space, light, and ventilation for air wells that are opening to for bathrooms, kitchens, bedrooms, etc. Their minimum dimensions relative to the height of the building. The taller the building, the bigger the minimum dimensions of the air well is. So if you design your air well that meets that criteria, yes, the air well is regarded as open to atmosphere for the purposes of the open corridor or open structure calculations. Yes, yeah, it does. Okay, what are allowed to be installed on the 40% opening? Louvers, grills, yes, definitely. But any impediment that you install will have to be calculated for its clear opening. So, for example, if you have 10 square meters of opening, 10 square meters on opening, and then you decide to put louvers across that opening, then you have to calculate the effective flow rate or the effective opening ratio of the louver that you put over the opening. So if the louver is 50% opening ratio, you put it over the 10 square meters of a clear opening, your 10 square meters is now 50%. So it's only 5 square meters. Yeah, and the spacing between the louvers or any of the impediments cannot be less than 1 square inch or cannot be less than 25 millimeter in dimension. Yeah, that's what it means. So if you put, say, a perforated screen in front of the louver, in front of your 10 square meter of clear opening, you put a perforated screen in it, and the perforated screen has got an opening ratio of, say, 30%, a perforation ratio of 30%, then yeah, you have reduced your 10 square meter down to 3 square meters effective opening. Yeah, so you have to calculate the effective opening of what you're providing. May I know if certain criteria was specified in MS Standard 1183, but not in any act of bylaw? Those standards need to be followed. The standards are exactly just that. The standards are just a set of standards. The standards are descriptive. The standards define normative practices, and the standards generally gives you good practices. The way the standards are enforced or the way the standards are made as law is when the UBBL refers to it. The example that I mentioned was that on the smoke control. So when the UBBL refers that smoke control smoke control shall be installed in accordance to Malaysian Standards 1780 2017 clause so and so and so, then that respective part of the Malaysian standards will become law. So the Malaysian standards in itself, or any standards for the matter, is not a law. It is just a standard, right? It is the UBBL that enforces the standard by referring to it, that you shall do it in accordance to Malaysian standards. Yeah. So that's how the UBBL has been gradually moving away from just mere prescriptions. For example, the section on the construction of fire doors. In the old UBBL 1984, you see that there's a clause, I can't remember what's that clause now. It has got this entire clause on how a fire door is to be constructed. That is taken out entirely now. The clause is just replaced by fire doors and all that shall be constructed in accordance to MS 1073. That is all. So the standards is then allowed to be improved all the time as we develop new standards, as we develop things. We keep improving the standards. And the bylaw just picks one reference. It shall be in compliance with the Malaysian standards. So as the standards gets improved, the law automatically catches up by referring to the latest standards. Yeah, that makes it things far more practical and far more. That's really the more effective way of ensuring that the design standards are kept up to date. We can't load up the bylaw to become too prescriptive. The bylaw has to refer to the standards. Right, okay, open corridor. What if the typical floor of apartment design as double-loaded corridor with air wells does not comply with the minimum surface area? Does it mean that we need to take requirements as per internal staircase core design? Yes, that's really what it means. It is not mandatory that you design apartment buildings with open corridors. No? If you aircon the entire building, you don't have open corridors. So what the prescription really says is this: for you to enjoy the prescriptions, or for you to enjoy the lower prescriptions that is allowed for by open corridors, your open corridor must be designed to comply as an open corridor. If the open corridor does not comply as an open corridor, you can still have it as an open corridor in the same manner that you design all the natural ventilations and all that. But you then have to follow the prescriptions for a non-open corridor concept. Yeah, that's exactly what it means. It doesn't say that you design an open corridor, it must be like that. If you can't do an open corridor like that, then you cannot do an open corridor. No, it doesn't say that. It just says on the prescription. For particularly references to the 10th schedule. Okay, if the sub-basement area more than 7,000 square meters has the perimeter opening more than 40%, can we declare open and open control center? Okay, it is not about waiving the smoke control, because the natural ventilation afforded by the open structure is your smoke control. So avoid using the term, can we waive the smoke control? No, open ventilation or the classification of open structure is one of your means of providing smoke control. Right, so smoke control is required for all basement areas. Smoke control is required, and for any space more than 1,000 square meters above ground, smoke control is required. Right, so it's just that, yeah, if you can actually design a lower ground structure that effectively complies with the requirements of that of an open structure via permitted air wells or air shafts and all that qualifies for that purpose, then yes, it will be recognized as an open structure. Yeah, but it's not about waiving the smoke system, because you are creating then a smoke evacuation system via natural ventilation as an open structure. Yeah, you just have to run it off with the engineers to ensure that there can be some means of proving that you are able to get cross ventilation, either by inducing some kind of suction or pressure, or complemented with certain mechanical air movement systems. You just have to look at it holistically. It's not about waiving the requirement of the smoke control system. For protected lobby to staircase for buildings between 18 to 45 meters, is it envisaged to be mechanically ventilated? Control of air change required. Okay, if it's an internal lobby, of course you need mechanical ventilation. If it's internal, from the space light and ventilation requirement, you do require mechanical ventilation, because all spaces need to be ventilated via natural means or mechanical ventilation. It is the requirement for this pressurization. When you have the pressurization, it is the mechanical ventilation will then have to have the additional pressure, the additional volume of air being pumped into it in pressurization mode. That means in active fire mode. Right? So normally you have to be ventilated. You design it to a certain degree of just slightly a small percentage above atmospheric bar, so that it's slightly positively pressurized by means of your ventilation, mechanically induced ventilation. But in fire mode, then the fans will have to be activated to then force in the amount of air change required into there, and to give you the differential pressure, maybe half a bar or 2 bars. I do not know. That one the engineers have to work it out for you. Ventilation is one thing. The pressurization is the other. And usually it's the same system. You just increase the pressurization. It's activated upon a fire alarm. Okay, does a staircase in a protected lobby need to be installed with fire door? Or a staircase in a firefighting lobby needs to be closed with fire door? Yes, definitely. Or you're talking about a staircase within the protected lobby. Now, technically, no. If the whole thing is the same protected shaft via pressurization, then you don't need to close off the door. But there is a good reason why we would want to also separate the fire stair from the protected lobby. That's a good reason, because firefighting operations is this. Very often, when the fireman comes and fight the fire, they don't go straight and fight the fire at the floor that's on fire. They will go to the floor below, because the floor on fire is the subject floor. They will go to the floor below, and then from the floor below, they do the staging, they do the connections and all that. Then they will take the stair up to the floor above that's on fire. And when they come to the floor above on fire, they have to, in a way, be incapacitating that protected lobby to fight the fire, because for them to access that lobby, they have to open the door to the floor on fire, right? So they will then require the fire doors on the stair to isolate where they're staging on the floor below, to be able for them to open up the lobby above to fight the fire. Yeah. So for good practice, there's absolutely no skin off our back for us to isolate the firefighting stair within the firefighting lobby with a fire door. Right? Absolutely no skin off our back. Yeah. No doubt you are allowed for it to be fully open, one continuous shaft, but do that so that it acts as a lobby, a protected lobby to the stair. All right. Next question. Wonder if a provision for full face gas masks in buildings would be helpful in a way of increasing survivability. Not at this moment. Not at this moment, because the general purpose, people just need to evacuate as fast as they can. That is the main criteria. So full face gas masks will not exactly be something practical in my opinion. But however, these things are applied in the old computer rooms and server rooms and all that, where we are still installed for situations where we're still installing CO2 suppression systems. Yeah, you do provide gas masks in there. You do know that there are people going to be in there, and then you have a certain protocol, a certain operating procedure when a fire detected, and within 10 seconds prior to the full activation of the CO2, alarms will be given. The personnel in there will be trained to get on the gas mask and start exiting the building. Yeah, but I think for general purpose, no. I would say a sprinkler system helps even better. A good design for evacuation is paramount. Early detection is paramount. Just get the people out as fast as they can. Putting on the gas mask will just delay the evacuation, in my opinion. Maybe it will help in certain areas. We just finished off the 2021 bylaws now, and we've increased a section, particularly on hospitals, evacuation in hospitals, evacuation for a person with disabilities and all that. So we packed up a lot more information on that. Yeah, maybe some of those areas we can consider as a supplement, that for the for areas like hospitals or places which are occupied, nursing homes and all that, which are occupied by recognizably by possibility of persons with disabilities in there, a lot of the installations in there require assisted evacuation. So yeah, maybe the provision of gas masks and other in those institutions will help. And that the people who are tasked with the task of providing assisted evacuation can don these full face masks for that purpose. Yeah, I see as a supplement. I don't see that it will be anything that we would need to incorporate it into a building design bylaw. Any minimum length of access way? What is the spacing between one access way to the other along the access road around the building? Okay, there are no real limitations over here. Minimum length of access way is determined by the minimum length of perimeter access. So if it says 1/6 is 1/6 or whatever the perimeter of the building is. So there's no minimum length per se, but I do not foresee that there'll ever be a situation where the minimum requirement of 1/6 of perimeter length is anything shorter than 10-20 meters. Yeah, because by virtue of the building volume that you're designing, so I don't foresee there'll be any situation where the minimum length will not be something usable. And the spacing between one accessway to the other, again, the primary purpose of the accessway is to have the frontage to the building and the access to the designated access openings and to the location of the hydrants and all that. So the accessway, if it fulfills its position in that position of the building, yeah, that is sufficient. There's no particular constraint or limitations as to how far one accessway should be to another accessway. Yeah? Just that the accessway in its location must fulfill its immediate relationship between the hydrants, reaching inlets, access openings, and access to the pump rooms, etc., etc. Okay, how do we determine the fire resistance period of wall doors and all that? Okay, that's in the schedule. You just look at the 9 schedule. Everything is in there by your building type, by your building volume, and by the building type, building volume, purpose group. Yeah, all the period of fire resistance is in the schedule. Yeah, in the bylaw. And all of that applies to all the elements of structure. That means everything that falls under elements of structure, the party wall, compartment wall, fire resistance rating of structures, beams, columns, floors, and all that, all carries exactly the same FRP rating as in the schedule. So if the schedule says your building is minimum 2 FRP, then yeah, all elements will need to be minimum 2 FRP. Okay, next question. If the building is in excess of 7,000 cubic meters, are we still need to provide 12-meter width for the access way, referring to the OUBL, or just need to provide minimum 6 access way? It's actually the same prescription. In the OUBBL, the reference to the building volume and the proportion have not been changed. It's exactly the same as it was before. The only difference now is that we have defined access way as minimum 6 meters, whereas the OUBBL is written as 12 meters. That has never been imposed. But the new 6 meter one is, again, I have to emphasize, is minimum 6 meters. It is not that 6 meters will comply at all times. It is minimum 6 meters. As the illustrations that I've shown you by the videos, in many situations, 6 meters is also not enough. So it is back to us as the architects to design what we feel is appropriate. And in any case, BOMBA can always override you. So say if you design it absolute minimum 6 meters all around the building with no consideration for turning turning angles, no consideration for maneuverability, U-turns and all that. You just draw a parallel. If we just draw a parallel line 6 meters apart surrounding the building in its exact configuration, Bomba will probably reject your plan. You can say that, oh, but I comply with it prescriptively. Its minimum is 6 meters, 2 parallel lines, 6 meters apart surrounding the building. But Bomba say there's no use because they cannot maneuver the fire appliance in there. Or if your building happens to be, say, a large warehouse or a very tall skyscraper, and you need to, Bomba will need to accommodate the parking position for the turntable ladders or for the giant hazmat vehicle. Say if you're in the industrial complex, they will need to bring the hazmat vehicle or the sky lifts. Those vehicles require a lot more maneuvering space and parking space where they extend out the booms. Extended boom may be already 5.5 meters or 6 meters. So Bomba can always override you and ask for more. That's why I'm always stressing the 6 meters here in the bylaw it says minimum 6 meters. It's not saying it shall be 6 meters. So when we design it, in the same way that we design road access for, say, articulated trucks. If you're designing, say, a logistics center or designing a warehouse, you got the loading docks and all that for trucks. We would naturally be designing the circulation and the road width and all that to accommodate the trucks, to accommodate, say, the 40-foot container articulated trucks. Or we locate the refuse bin collection, the RoRo bins. We will naturally be designing the frontage of the RoRo bin structure to accommodate the moving of the delivery and the moving of the trucks carrying the bins. They have to park and then load in your bins and load out. So we'll naturally be designing for that. Nobody tells us that you put a 3-meter road in front of a RoRo bin. We don't do that, right? We naturally design it for access of the vehicles. So likewise the same, when we design accessways, naturally design it for the use of fire appliance access for them to park. I've shown you the videos. If we look at the videos, you'll find that, wow, the fireman really requires a lot of space for safety, for protection from falling debris, protection from the radiant heat, laying out the hose and all that. So 6 meters is just the absolute minimum. Do look at the configuration of the building that you design. Where have you located the tanks? Where have you located the hydrants? Where have you located the access openings? And give the correct or give an appropriate width and configuration of the accessway. In any case, if you have any doubts, do talk to Bomba. They'll be more than happy to assist you. They'll be more than happy to advise you, rather than just drawing 2 parallel lines 6 meters apart. Bomba will probably reject you, even though you are actually strictly in compliance with the bylaws. Can there be a canopy fronting the accessway? All right, on the access road, yes. Where you demarcate specifically as an accessway, particularly the width. If you're demarcating the width to be measured from one edge to another, that width and that accessway, there shall be no canopies. There shall be nothing above your demarcated accessway. There shall be no obstructions above where we as architects demarcate as the accessway. The road can be very wide. You can have the full compound 10-15 meters and all that, and then you have the canopy extending over 5 meters. Not a problem. All you do is you demarcate the accessway away from the canopy. The accessway doesn't necessarily have to be the entire width of the road, curb to curb and all that. No, you don't have to do that. It is where you demarcate it as an accessway. So yeah, you cannot have an accessway underneath a canopy. Okay, I've seen projects which Bomba fire truck cannot turn into the accessway for apartment project due to the turning radius is too tight. Does the UBBL adequately address this? No, because again, like I said, the UBBL will not have prescriptions on how you do turning circles and all that. In the same context as the last one or two questions, when you're designing the accessway, we do have to design it for the accessibility of fire engines in the same manner that we would design our car parking, our ramps and all that to accommodate the movement of the cars that you intend to use the car park. If you're designing a logistics storage area with loading bay for trucks and all that, we would want to design, we should be designing it for the adequate maneuverability and the turnaround of all these trucks. So likewise, when we design the accessway, take it that it is an absolute requirement and our obligation. If we demarcate that as an accessway, yeah, we must be designing it for the proper and the correct maneuverability. Yeah, in this example that you mentioned, Bomba can, in the issuance of the fire certificates, they can point out that non-compliance and insist that you correct it before they issue you the fire certificate. They can do that. That's why Bomba is given the full empowerment on the enforcement side for them to check on all of these things, all of these non-compliances. Would we get lecture notes for this lecture? Yeah, I think all my slides are available. Yeah, Justin, you have access to all my slides. In any case, I'll make sure they have it. Yeah, you have full access to it.
Yeah, and just to let the participants know, it's also the webinar is also posted on the PAM Sabah Facebook page, so you can go back to watch it anytime.
Right. Okay.
Yeah.
Okay. Thanks. Yeah, my notes are not patented. Is neither is it registered or copyrighted, and it has been much copied and abused and circulated over the years already. It doesn't matter. All these are common knowledge, and it's just out there. Just use it correctly. Don't quote me wrongly. Just use it, study it, and enjoy. It's all for the it's all for the betterment of our profession.
I think just with that, Architect Chong Lee Siong, I think there's a bit too many more questions to go through. What we might do, we will we'll compile the questions like with the previous session, and then we'll email it to you.
Okay.
And then you can address the questions, and we'll email it back to all the participants.
Okay.
Yeah.
I think that'd be great. Yes.
I think that would be better.
Yes.
I think, and that would officially conclude the session today. Thank you very much for the very informative session. Good refresher for everyone. And yeah, thank you very much for today. Okay, so all the participants, this officially concludes the session today. Thank you for tuning in, and your questions will be addressed and we will email it back. Please don't forget to fill in the feedback form and state your email address so that the PAM Sabah office can email it back to everyone. Thank you.